All right. Hey, everyone. Welcome to the distribution demo for November 12th, 2020. My name is Dustin Collins, and I'll be showing off some Openshift cluster automation today. Before I get started, big thanks to Gerard from our team and Edmund from Red Hat for reviewing this work. Okay, so you can see on the right side here, I have already started creating the cluster because it takes anywhere from 25 to 40 minutes. So I kicked this off about 20 minutes ago. So we're not sitting here waiting for it. That said, we are keeping the Highwire live demo. Things could fail. So let's just continue forward on that. So while we're waiting for that, I can talk a little bit about the background for this project and go into the scripts themselves. So we're working on a Red Hat or a Openshift operator in this project here. And one of the things we need for this is easy, reliable way to stand up Openshift clusters for testing, both for developers to launch clusters locally and then also to use them for CI so we can run some tests against it. So that repository is here on the left. This issue 47 is what we're talking about today. But to dive into the scripts a little bit, Openshift provides this Openshift install CLI. It's actually mirrored on GitHub. Under Openshift installer. So basically this is a Go CLI that wraps Terraform and some logic to stand up an Openshift cluster on. They have a bunch of supported providers now. We're starting out with GCP just because that's the default for our team. We could add, AWS as we go. I'm not sure if we'll run into cloud provider specific issues. We might, where something's working on GCP and not working on AWS or vice versa. So we'll cross that bridge when we get to it. But it's nice that they provide this installer tool because we don't have to write our own Terraform code to get clusters going, which it might seem simple because we're just kind of standing up 6 instances and configuring them, but they all have to talk to each other. And the way that this installer tool actually works, and you can see it here on the lower right, it actually creates a bootstrapping instance. So Terraform stands up the bootstrapping instance, and then I believe on the bootstrap instance, it's also running different Terraform resources to stand up the control plane and the workers. So by default, the Openshift cluster has 3 master nodes and a control plane that are also running etcd, and then 3 workers. That can be configured as far as the workers, but as far as I understand, we will always need three master nodes in the control plane so etcd can reach quorum. It would be kind of nice to just have a 1 master, 1 worker cluster. It's pretty lightweight for testing, but in my experiments anyway, running less than 3 masters always resulted in errors. So that's how we're going with it. Thankfully, they do have a config file for your cluster. This is this install config template in the scripts directory of the GitLab operator project. You can see that here on the right. And it's a mix of Openshift configuration and then underlying cloud provider configuration. So for example, we're saying things like we want to use the Openshift software-defined network as the network type. They have some pretty good documentation, which is linked from our documentation there about all this customization you can do for the network and the machine nodes, but this is pretty much the standard install config template to start with. You know, we can tweak it as we need. For example, if we launch some CI clusters and have issues with, you know, resource consumption, we can always bump the type of these nodes up higher. By default, I think they are 4 CPU cores and 16 gigs. So they're not, you know, wimpy instances by any means, but there is a lot, as I'll show you. And here in a few minutes, OpenShift runs a lot of different software as operators, just standards. So just running those operators is, you know, that could easily take up probably 8 gigs of your memory. So we need to use bigger machines here. So really the shell scripts that I've written for this create cluster and destroy cluster shell here, they are just wrapping the OpenShift install tool. But one of the interesting things about this tool is that like you create your install config.yaml and then you run OpenShift install and point it to that. OpenShift install that CLI actually consumes and deletes that file once it's done, which I guess I'm not sure why that happens, but this create cluster shell script is basically, you know, just making sure that you have the OpenShift install and OC tools, and then it is using this template to render in different configuration. So you might have noticed when I was showing the config template, we have this like cluster name and poll secret and SSH public key. So the variables for this file are secrets, you know, that you wouldn't want to commit to this file, like the poll secret, but also just, you know, kind of templated values that we might want to switch up. These are all documented. Let me switch to the nice looking one. This is the doc for these scripts. It's in the doc folder in the OpenShift repo, but it spells out configuration is passed via environment variable, and then it's rendered into the template. So we have that all documented here. That said, as it says here, there are no required options. So if you just run this, it has same defaults for everything. So you really only need to start playing around with the configuration if you want to change things. You don't have to really even know about it if you're just trying to run the tool to set up a standard cluster. And so after create cluster renders that config file, then here it's actually creating the cluster where it's wrapping the OpenShift install tool. And so that is what I've run here on the bottom terminal. You can see I overrode the cluster name to call it OCP demo. OCP is OpenShift Container Project, which is the flavor of OpenShift that we're using. So that's running along here. So this creating cluster is really a 3-step process. So first of all, it generates a bunch of Terraform files and sticks it in this install directory, which is get ignored in the project. You can see we've got, you know, state files, vars. But this install directory also contains the kube config and the kube admin password for when the cluster is up and running, so you can interact with it from, you know, K9s or kubectl or whatever you like. These files live here. So, you know, while doing this, you know, one of the main reasons the create cluster script takes environment variables as configuration is because, and maybe someone on the call can tell me more about this, but I envision, for maybe our first pass to set up CI clusters, somebody could just run it from their local workstation and then put the secrets in a GitLab CI variables so the jobs can talk to the Openshift cluster. But it would also be nice to run this create cluster script from CI itself, as sort of a one-off manually triggered job. That way, if somebody that at least that way we have an audit log of what clusters have been launched and with what parameters. But I don't know if we have any examples of that kind of one-off infrastructure creation job at the moment. So I'm going to pause for a second. If anybody wants to talk about that or has any questions about this create cluster script so far, please speak up.
So far, this all seems fairly straightforward. We have run similar things in the past. A long time ago when we were doing, well, in GitLab years, when we were doing the work with one of our partners to Cloud Foundry, we actually had a specific pipeline that effectively did a very similar setup. It spun up a bastion and then exploded everything into play. And then later on, you would shut the pipeline down and would reverse that process. So this seems very similar to that, which is good. We have a strong sense of what the state needs to be. We have a strong sense of how and where it's going to be operated at, and the ability to do it in a relatively immutable fashion, which is what's needed.
Okay, thank you. One other, well, this cluster should be completed here soon, and then I could show the Openshift console, the kind of the resources it's created at GCP. But while we're waiting for that, we also have this, destroy cluster script, which is a lot simpler than create cluster, but again, it's just wrapping the Openshift install tool here. One interesting thing here is that I previously, this install directory that holds all of the cluster information is get ignored. So at the end of the script, originally I had, rm rf install because it's no longer needed, right? You've deleted the cluster. But I ran into a situation where, anytime you're dealing with cloud providers, there's the potential for timeouts, right? Or just some network flakiness. So if you run this destroy cluster and something goes wrong, and then it won't report, like it won't return a non-zero exit code. Sometimes it'll just say it's destroyed, moving on. And then if after that you remove the install cluster and then go back to Google Cloud and verify that everything's down, if it doesn't actually destroy the cluster and you delete the install directory, that's the state file for Terraform. So you can no longer delete the your OpenShift cluster automatically. And so I removed that line, removing the install directory, because I had to the other day delete an OpenShift cluster out of GCP, which is like 40 or 50 resources that are all connected to each other in various ways. And it's not fun. I don't recommend it. So keeping that install directory around is helpful. It fills up with information when you're launching the cluster, but after you delete the cluster, it really only has this OpenShift install log, which is just a very long log of everything that it's putting to standard out here too, if you were in debug mode. So that's just something to keep in mind. Like if you're gonna delete your install directory, just make really sure that your cluster is indeed already destroyed, because deleting it by hand is pretty time consuming.
And considering the amount of artifacts that get left behind, basically it's a log, I don't think it's really a problem to leave that created directory around.
Yeah, right. Yep, and it's get ignored too, so it'll never be checked in. Yeah. What we do expose this log level environment variable, which is passed through to the OpenShift install tool too. So if you are working with this and something goes wrong, the first step is probably to set log level to debug because it puts out a lot more options. So you can see here in the lower right, I think we're almost done. If I had debugging log on, I would have a better view into what was actually going on. But since I've done this dozens of times, I know that these three waiting calls up here are the three steps that are taken to launch the cluster. So first of all, you're launching the master or the master nodes, the control plane here, and waiting up to 20 minutes for it to be ready. Then you are launching the worker infrastructure and waiting up to 30 minutes for it to be ready. After the control plane nodes and the worker nodes are up, the bootstrap resources, which is basically another instance with some associated service accounts, is then destroyed. And then this last step that we're waiting on here, waiting for the cluster to initialize, is basically just waiting for all of those different operators that are running in the cluster to resolve. So they're just, they're just in a loop waiting for, other resources that they depend on to be ready. And that is probably the most time consuming thing here, where we're just waiting on the operators to be ready. But it has completed. So let's go ahead and open up the OpenShift console here. One of the improvement we can make here is, I don't know if they provide it out of the box, but it would be nice to have a Let's Encrypt setup instead of having to, accept the security risks as you go through, because it's using self-signed certificates. Hopefully there's an easy way to do that. It puts out the admin password or username and password here. It's standard out. But this password is also saved in the cube admin password. So you don't have to save standard out if you don't want. But all right, cube admin password. All right, so yeah, we have our OpenShift cluster here. You can see a cluster version update is available. OpenShift is moving pretty fast. Like when I started this project, like a week and a half or 2 weeks ago, the latest OpenShift version was 4.5.3, and now we're up to 4.6.3, which is the latest. And so we've talked about what minimum version will support, and it sounds like 4.6.1 will be a pretty good bet, at least to start out. I did have a bunch of issues with this OpenShift install tool launching a 4.5.3 cluster, where it was like 1 out of 10 clusters would actually complete to launch. Otherwise, there'd be timeouts, and it would just fail out. Like the workers wouldn't come up, and then I'd launch it again, and they'd come up fine. But since switching to OpenShift 4.6, I haven't had any of those issues, and cluster creation actually went down from like 45 minutes to like 30, 35 minutes. So that's nice that that's improving. Yeah, the only thing I want to show here in the cluster is, I'm looking at the pods here. Well, actually, let me look at the deployments. So these are all the operators that are in the cluster by default. So, there's a lot of them. So it's not that surprising that the longest part of launching a cluster is just waiting for these to settle down and become ready. Yeah, I mean, the Openshift cluster is pretty full featured, so you can go through here and check things out. Um, Another nice thing is that I'm in the project directory here for the operator. You can expect this with K9S as well. So if we look in the install directory and the auth directory, um, okay. So if I set my kube config to install auth kube config and then launch K9S, yeah, you can see yeah, you can see it just the same as you're used to seeing K9S. This is also a good way to debug why a particular operator might not be stopping or starting, because when you're launching a cluster, you can this kube config file is created after the second step. So you can, if you see that it's waiting for a while for the cluster to initialize, you can pop into K9S and start inspecting these different operators and their pods to see what the issue might be. So that's helpful. Okay. I guess one last thing here is that when you are logged into your um, Red Hat account, there's like an OpenShift, and I'm not logged in right now, but I'll just describe it. There's a cluster manager in there, OpenShift cluster manager, that is supposed to show, like when you launch a cluster like this, it'll register with Red Hat, and then you can view that cluster from that dashboard and um, see your list of clusters with some metadata. But I don't know why, but it's not showing. The clusters that we're launching are not showing up in there currently. So I guess that's another thing to look into if we care. But at the same time, each of us has a separate Red Hat login, and so that would only be our clusters. So it wouldn't be a view of like every cluster that the distribution team has launched. So I would say its utility is limited, just because of that scoping. Okay. Um, well, I'll open up to any questions, concerns, comments. I'm going to go ahead and destroy this cluster in the background while that's happening.
So the only thing I want to toss out here is when we consume this ourselves in CI, does it make sense that we'd have the ability to configure the Terraform to store its state within the project? Can we dog food our Terraform state?
Yeah, you mean instead of like a GCP bucket like it's doing now? I don't know. I mean, one issue with state files is that they contain secrets, so checking them in might not be the best way to go.
No. We don't. That's not how that works. We don't check them into Git. We have a Terraform state management component within GitLab now. What I'm saying is, do you think it would be possible for us to configure this script in such a way that we can convince it to stash it through that?
Um, I didn't see that looking through the documentation, but it may be possible. There is a lot of activity on this OpenShift installer directory. It actually has issues and stuff, so we might be able to add that in if it doesn't exist. What benefit would that give us?
Basically, we would be able to have one centralized, in terms of our CI, we'd have one centralized location for where everything is. We wouldn't have to worry, did we ship this off before? Did we make sure that the CI's got the right access? Because we got to be really touchy about access to a GCP bucket if it's got this kind of information. Basically, it's just, can we do this in that fashion that we already know is secured, and then make use of that as a dog fooding item, because it's one of the reasons we have this, is to be able to have the Terraform state for environments.
Yeah, that'd be interesting. You know, I don't think it supports it now, but if it's something we want to do, I think we could get it merged in. You can see here in the bottom right all of the resources that it's deleting. By default, it does create a VPC, and each cluster has its own VPC that has its own firewalls and everything. So I feel like it's pretty secure by default looking over the infrastructure for it. All right, there we go. Delete takes about 3 minutes, so that's not too bad. Yeah, so as a follow-up to this, we'll have an issue for actually creating some CI clusters, and that'll probably involve, you know, setting up an initial sort of smoke test for the operator. Does it install fine in OpenShift without airing out? And then we can kind of build off that. But yeah, that's all I had for the demo. Are there any last comments, questions, concerns? All right. Well, thanks for attending, everyone. We'll see you next time.
Thank you.
Yep, bye.
Thanks, Dustin.
Bye.